Hi, everyone. Thanks for coming to the talk, How to Build Your Own API Universe, Bridging Resident WebSockets. I'm Viktoriia, and today I will be walking you through the WebSockets, actually not webhooks, WebSockets theoretical part. Firstly, their advantages, their limitations, and also when to use them. And also then the most interesting part will come to game. That will be about how actually we made use of the WebSockets to build our own solution. Just briefly introducing myself. I'm Viktoriia, technical architect in Omnevo, actually quite small company, and we support retail shopping solution for the airline and also airports. And I started as a Java developer, then switched to the business analyst, and then landed as a solution architect. And as for the passion, I like building the solutions when I have just one blank page. And outside of the work, traveling, physics, and sport. So, and let's start from the theory. Who of you probably already used WebSockets? OK, great. Then that will be boring probably for you. WebSockets, what they are. First of all, WebSockets are a communication protocol that allows persistence two-way communication between client and server side. So unlike HTTP, actually, where the client usually sends a request every time to get a response, WebSockets, they remain open once you have successfully initiated a handshake between them. And then that means that actually client and server, they both can send messages anytime they want. And in case if you compare that, that's actually like moving from emails to the phone calls, because with email, you just send something. And with the phone calls, once picked up, then you actually can talk to each other without any limitations. And that actually makes WebSockets perfect for the real-time communication. For example, live charts, some dashboards, shared ones, and also the connected devices. What about their strengths? First of all, as said, that's about the full duplex communication. Here we have client and server. They both can send data at any time they want. And additionally, as for the WebSockets, as I said, we have the concept of first handshake between them. And once we have it, then we have like a channel established between each other. And that reduces the latency because, for example, in HTTP, you need to send every time all those HTTP headers. Usually the requests are followed by the authentication information, content type, and so on and so on. With the WebSockets, that's actually not the case because with the WebSockets, you initially just handshake and then here you are. And that actually leads to the efficiency because that actually significantly reduces the loads on the server because that also is not spammed every time with the pooling, for example, when client needs to get the information about some updates, at least their presence. And last but not least, that's about their wide support. So currently, the majority of the browsers, I checked like really lots of them. At least I haven't found anything what I was not familiar with. Frameworks, backend libraries, everything supports currently WebSockets, and in short, they are fast, they are efficient, and they are great for the real-time communication. So when to use the WebSockets? So first of all, as said, real-time communication. Here we have almost no restrictions because we just keep open our channel, and then client and server, they can. What? That's gone. OK. Yes. actually, client and server, they can just communicate with each other, and once some kind of updates come in, so they can just be picked up. And additionally, one of the advantages that server actually don't need to wait for the incoming request, because like usually when you need to get some kind of updates. Usually that's about polling every 2 seconds for getting this update finally, and that's significant load on the server. With the WebSockets, that's not the case. And then that is covered by the bidirectional data exchange, and for the continuous updates, well, actually, REST is great for the cases when you have one-time requests, for example, for loading some kind of configuration, let's say. But for the WebSockets, when we talk about live dashboards, let's say, we have constant updates, and we need to keep all our users like to be synced up. And actually, WebSockets are quite great here. And that's also applicable for the collaborative applications. But as all the other technologies, WebSockets unfortunately have some limitations, and there are a lot of them. So first of all, that's about scaling complexity. So here, in case if we compare with REST, once again, in REST, actually, that's about just getting one request, all the information with it, with the headers, and then actually you can forget about it. With the WebSocket, you need to know every your client, because once the connection is established, you need to handle this channel. And that actually also leads us to the overkill for a simple request, because again, in case if you need just to get, let's say, product catalog once per day, you cache it on your site. With WebSockets, where you require usually constant updates, that's actually almost useless to implement WebSockets, because you will need also to maintain them. And also very important, at least that was in our case, that's about the message size limitations, because majority of browsers, they allow only like a limited message size. As for the connection management, unfortunately, that's also to be kept in mind, because with the WebSockets, you need to deal with the retries, let's say, reconnection, because, for example, WebSocket server might be down, and then you need to reconnect, so you need to know how to initiate once again the event handshake, for example. And for the limitations of cachings, here we also have some restrictions or let's say limitations from the browsers, because WebSockets events are not cached in browser or CDNs. And coming to the most exciting part, at least for me, that's about post-aircraft. So I believe you have seen something like this. So shopping solution, when we are talking about in-flight entertainment, probably you have seen or used them. When you have a seat monitor, you can browse some products and order them to be delivered to your seat, actually. And then we have point of sales. Also, probably you have seen the crew members when they go through the plane and just sell some items. They have those terminals for like selecting the products and also performing payment. What we had here, first of all, we had to establish the communication between our aircraft service that was deployed to the aircraft server, and then all of the POS devices. Then, unfortunately, those guys, as POS devices, they have the limitation that they act only as clients. So basically, they can't perform as a server. And additionally, in case if you are talking about, I don't know, Boeing 777 or Airbus A380, those aircraft are quite big. And usually, as for the procedures, crew members, multiple of them perform the sales. And therefore, we need to synchronize all the POS devices, especially when we are talking about the limited stock availability, for example. And we have only one item in the airplane to be sold. And then we need to synchronize the data between the aircraft service and all the POS devices. So our solution architecture we came to. So we have this aircraft service that is deployed directly to the aircraft server running in the airplane. And additionally, one of the important limitations I forgot to tell about, that's about having, first of all, internal network. So as for the Wi-Fi, we used the cabin Wi-Fi, and additionally, as for the satellite connection, well, as you can imagine, we had to reduce the number of calls because they are quite expensive. So on the aircraft service, we have our aircraft WebSocket running, and then we have all of those guys as the POS devices. And we came up with having, so to say, a hybrid architecture where we had as a backbone of the solution REST API communication between the POS devices and the aircraft service. And then for enabling runtime communication and also frequent updates, here we use the WebSockets. So as outcome, first of all, we gained here POS connectivity, because in general, here we had an issue, as I said, that unfortunately, POS devices, they can't act as servers, and therefore, in case if actually that was our case, we had to produce some calls towards them. Unfortunately, we had to find a way of how to reach them, and WebSocket was the solution here. Secondly, that's about data synchronization. Actually, that was one of the current limitations of current POS device solution when they just run without IFE, in-flight entertainment. In the aircraft, because with the Apples, for example, with iPhones, there is one of the issues that, for example, in sleeping mode, they can't get any notifications in. So with the aircraft service and WebSocket, we solve this issue, because then they can get this data and all the updates, because WebSockets are acceptable by Apples also to be executed in background. And then traffic optimization, because as I said, we had one of the issues that's about the internal cabin Wi-Fi, and there obviously we have some limitations in terms of speed, also connection reliability, and unfortunately with the server stability. And that's actually also what quite great advantage of WebSockets, because we were able to reduce the load on the server, because you can imagine that in case if we compare the server in the aircraft and Kubernetes, we have not the same. So actually, coming to our particular use cases. We had to cover especially 3 use cases where WebSockets were utilized. The first one was about cell session. So when a new procedure is started, then cell session is to be opened, then all the stock information, of course, to be loaded, because usually that is maintained on the POS devices, not an aircraft service. And then additionally, placing an order, because we need to get the money from the passenger. And here's the description about how passengers interact with the aircraft service and crew member. So let's imagine some of the passengers that they decided to put some items to their baskets. One of the guys successfully came to the order page, created a new order that was paid. For the payments, we used, unfortunately, satellite connection. And then actually this order goes successfully to the aircraft service. And then what we have here, aircraft service triggers a new event to be generated to the WebSocket. And actually, that's already a first advantage of WebSockets, because POS device was not a server. We were not able to send any requests to that. But with WebSockets, we can do it. And actually, we have bidirectional communication. So POS device can also initiate some kind of events to be sent to the aircraft service. And then once new event comes to the post device, so post device just presents some kind of notification to a crew member that a new order came in. And here, coming back to the so to say, concurrency between the crew members, because we can imagine that we have multiple crew members handling the sales procedures. And then, for example, two of them decided to accept the same order. So to eliminate the situation when those guys simultaneously come to this pure passenger with all the goods, we decided to come up with the solution with having who first pressed the button, that wins. And here, post device, once a crew member, for example, presses accept button, then post device sends a new event towards the WebSocket, like a order status itself that it was accepted, and additionally device ID. Device ID is needed to log particular device that it belongs to the a crew member who accepted the order. Then, once done, then aircraft service produces a new event with the order ID. So we accepted, we decided that this order can be served. And then here REST comes into play. Then post device goes to the aircraft service and already requests all the details. Why that's needed? Because of the size limitations. For example, as for now, we have a limitation, if I'm not mistaken, that was about 5 megabytes or something like that. So quite small. And for example, we can't provide all the details belonging to the order within one event. And that's easier just to send everything to REST here. And then we have a normal communication, request response. And then actually, when response is received by post device, then it presents the summary to the crew member, and crew member just prepares the order to be brought to the passenger. So here we are, and here I wanted to highlight so that we used, first of all, the settability and absence of limitations from the REST from size perspective, and additionally, we we're able to get some of the advantages from the WebSockets of having no restrictions from the both sides communication. That server can initiate a dialogue with the client, and also that we have runtime communication. So as a keynote, first of all, that's about having the differentiation between REST and WebSocket. REST is great, really great in terms of having stable, static structure to be requested and to be fetched from your server, for example. But in case if you're talking about real-time communication, here I would say WebSockets are real preference. And in case if you combine both, actually you can get use of all the advantages from both sides, because, for example, with WebSockets, you don't need to provide every time all the HTTP headers, what also reduces the load on your server. And that's why, well, for me, that's clearly voting for the hybrid solution when you utilize both. And thanks.